Good morning, students. I welcome you for the chemistry class. Today, in this video, you'll be studying about solution, different types of solution, problems based on that, like how to find out the concentration, mass percentage, volume percentage, what is solubility, and problems based on solubility. Here we go with about the solution. A solution is nothing but it's a uniform mixture of two or more substances. Homogeneous mixtures are solution. Solutions are of like liquid into liquid. So liquid dissolved in liquid, water and ink. Solid into solid, alloy. Gas into gas, air. Solid into liquid, sugar and water. Solid into gas, it is hydrogen and metals. Liquid into gas, carbon dioxide and water. So solution consisting of two types of substances, a solute and a solvent. A solvent is which another substance is mixed. Now, always solvent will be present in a larger quantity. Example, water. So, it's a universal solvent. It dissolves most of the substances. So, it is called dispersion medium. Coming to solute. The substance that is added to the solvent to form a solution. So, solute is always in a limited quantity, right? And this is known as dispersed phase. Example, salt or sugar added to water. Next, coming to properties of solution. A solution is always a homogeneous mixture. We cannot see the particles through our naked eye because the size is very small, it is less than 1 nanometer. And the path of light is not visible through the solution. The particles of the solution do not scatter the light because the size is very small. So, Tyndall effect is not seen in case of solution. We cannot separate the particles of the solution by the methods of filtration. Next, let us know what do you mean by stable solution. Stable solution is a solution in which those particles do not settle down if you leave the solution undisturbed for some time. The particles of the stable are homogeneously spread. Coming to different types of solution. Aqueous solution, a solution in which water acts as a solvent. Non-aqueous, a solution in which water is not a solvent. For example, carbon disulfide, petrol, kerosene, alcohol, sulfuric acid. So all this comes under non-aqueous solution. Coming to solution can be diluted or concentrated. So what do you mean by diluted? Diluted in the sense the amount of solute is less compared to solvent. Concentrated, the amount of solute will be more compared to solvent. No, amount of concentration of solute will be more. That is concentrated. If it is less, then it is diluted. What do you mean by true solution? A solute particles completely dissolve in solvent and it cannot be visible. For example, sugar in water. Saturated, a solution in which no more solute can be dissolved at a given temperature. So highlight at a particular temperature. Unsaturated, a solution in which more solute can be dissolved at a given temperature because temperature has an effect. So when you increase the temperature, solubility of the solids can also increase because of this. So again, it's a different types of solution. You have a theoretical thing where you can watch the slide and you can write down the notes. So same thing, it's there. Okay. Next, what do you mean by supersaturated? Supersaturated solution is when a solution which contains more solute than would normally dissolve at a certain temperature. For example, to make 1 liter of saturated solution of NaCl, it requires only 39 grams. Now, only 39 grams of NaCl can dissolve in 1 liter of NaCl. So, they'll say that as saturated. If further salt, say up to 50 grams, is added by increasing temperature. So, when you just increase the temperature, what happens? So, the distance, like the interparticle space, increases, kinetic energy increases, so that more amount of salts can occupy the spaces in between. So, it can accommodate 50 grams. So, then your solution is said to be supersaturated. Coming to difference between true solution, colloidal and suspension. So, dear students, we already studied in the concept in 8th standard. So, quickly we'll go ahead with this concept. So, true solution is homogeneous mixture of solute and solvent. It is transparent. The solute particles are smaller in size, less than 1 nanometer, and they are not visible even with a powerful microscope. The entire solution passes through the filter paper as well as semi-permeable membrane, and the solute particles do not show Tyndall effect. The particles do not settle down due to the gravity, so it means they are stable solution. Coming to colloidal solutions, they appear to be homogeneous, but actually it is heterogeneous. It is translucent, and the particle size is between 1 nanometer to 100 nanometer, and the particles are visible with the help of microscope. The particles can pass through the ordinary filter paper but not through a semi-permeable membrane. These particles will show Tyndall effect. The scattering of light is seen in case of colloids, and the particles do not settle down due to gravity. For example, blood. So these colloids is also a stable solution. Coming to suspension, it is heterogeneous mixture. It is opaque, and the solute particle, the size is more than 100 nanometer, and they are visible through naked eye. They cannot pass the filter paper or through a semi-permeable membrane, and they may or may not show Tyndall effect based on the size of the particle. And the particles will settle down when you just leave it for a few minutes. It's because they're not stable. The particle size is so much bigger so that it's settling down. So example is chalk powder in water. So you can get the question. So at least 6 points. You should be thorough with the difference between true solution, colloids, and suspension. So this is what a Tyndall effect. So what we have studied already. So there's no scattering of light in solution. In colloids, you can see the scattering. The path is visible, and in case of suspension also you can see, because the particle size will be much more greater compared to solutions. So these are the things. So based on this, you have to substitute the problems. So you have to solve the problems. First is concentration of a solution. It's nothing but amount of solute in the given amount of solution, or the amount of solute and the given amount of solvent. So whenever it is percentage, you have to multiply into 100. In that, you have to study the mass percentage and volume percentage. The formula used is mass of the solute divided by mass of the solution into 100. So this is for mass percentage, like solids. So whenever you take liquids, so it will be volume percentage. So mass of the solute divided by volume of the solution into 100. So these formulas you have to make a note. So the problems will be based on this. Coming to the problems, a solution contains 30 grams of sugar dissolved in 370 grams of water. So mass of the solute is how much? 30 grams. Solvent, how much is there? 370 grams, right? So calculate the concentration. So concentration formula you have to write down mass of the solute divided by mass of the solution into 100, because it is solid. So that's how this formula. So what's the mass of the solute now? 30. Mass of the solution. So what they have given is only the water. How will you get solution? It is solute plus solvent. So 30 plus 370, you get 400. So divide by 400 into 100. So you get 7.5. So listen students, whenever they give water, but the formula says solution, then you have to add solvent plus solute. Okay. Then the second problem. If 110 grams of copper sulfate is present in 550 grams of solution, calculate the concentration of solution. So understand the question. What is the mass of solute? It is 110 grams. So what is the mass of the solution? So they have already given about the solution. Means it contains solute plus solvent. So 550. So write down the formula. It is 110 divided by 550 into 100. So you get as 20%. Next, coming to volume percent. A solution contains 50 ml of alcohol mixed with 150 ml of water. Calculate the concentration of the solution. So this is now the liquid. So you have to take the V percent. So volume of the solute divided by volume of the solution into 100. So now they have given only water. So what's the first thing you have to do? You have to make solution, right? So solute plus solvent. So 50 plus 150 gives 200. Whereas volume of the solute is only 50. 50 divided by 200 into 100. So you get 25%. The next problem, if 2 ml of acetone is present in 45 ml of its aqueous solution. So I already given about the solution. So calculate the concentration. So volume of the solute is 2 ml now. Solution is 45 ml. So write down the formula. So it is 2 divided by 45 into 100. It gives 4.4%. Now, the next concept is about the solubility. What do you mean by solubility? It's a maximum amount of the solute which can be dissolved in 100 grams of solvent at a particular temperature. Please highlight this key term. Particular temperature is known as solubility in that particular solvent. For example, temperature is around 20 degrees. So copper sulfate can dissolve, like 21 grams of copper sulfate can dissolve in 100 grams of water. Potassium nitrate, 32 grams can dissolve in 100 grams of water. So standard is 100 grams of water. Okay. KCl, potassium chloride, 34 grams. NaCl, 36 grams. Ammonium chloride, 37 grams. Sugar, 204 grams. So this particular grams is for this particular temperature, that is at 20 degrees, and it's for 100 grams of water. So any changes in temperature and the solvent, so the solubility also varies. Okay. Next, conditions affecting solubility. Temperature. Solubility of the solids in liquids increases with increase in temperature, whereas solubility of the gas in liquid decreases on increasing the temperature. When you just keep it the water for boiling, you can see the bubbles, right? So you can see those gas, the bubbles what you get, the gas particles will start escaping. So that's how the solubility of the gases and liquids decreases on increasing the temperature. Pressure. Solubility of the gases in liquids increases on increasing the pressure. So that's what you see carbon dioxide dissolved in water, increasing the pressure in all the aerated drinks. As soon as you release the pressure, what happens? You can see the solubility also decreases, whereas solubility of a solids in liquids, so there is no pressure effect on solids and liquids, so they remain unaffected here. Okay, then, so there's a problem based on solubility now. 12 grams of potassium sulfate dissolves in 75 grams of water at 60 degrees. For this, they'll give a particular temperature. So this particular temperature, only 12 grams can dissolve in 75 grams of water. So what is the solubility in water at that particular temperature? Now, 75 grams of water dissolves only 12 grams. Therefore, for 100 grams of water, how much? So you have to cross multiply. So 100 into 12 divided by 75. How much you'll get? 16 grams. So 16 grams of water, 16 grams of potassium sulfate can dissolve in 100 grams of water at the temperature 60 degrees. So if I change the temperature, what happens? The solubility will automatically increases. Okay, you have to note down this. Temperature has an effect. Okay, thank you. So we'll continue the rest of the concept in the online classes. Thank you. Have a nice day.